So we've got factoring, we've got quadratic formula, we've got square root property, we've got completing the square. 4 different ways to solve quadratics. So now it's at the point where we're going to take things that may or may not be quadratics or start as quadratics, turn them into quadratics, and then use those tools to solve them. Okay? So some of this stuff we've done a little bit before in the past. Now we're bringing it back. It's all full circle. So there's this general kind of guideline. If your equation starts in the form ax plus b squared, you have a binomial square. You have a variable squared. You don't have the variable in there more than once. Then it's already set up for square root property. We're going to use square root property. But equations in that form are fewer than anything else. They're rare. They don't happen all the time because those would be too. Okay? Most of the time, we're going to need to get our quadratic into standard form instead. And then from there, we have a choice. Can I factor it, or do I need to use quadratic formula? When you can factor, you're going to want to factor, because the first instinct with so many students is to go straight into quadratic formula. Problem is that for some of the harder examples, it doesn't necessarily work. Also, quadratic formula has more room for error. But we're going to use the quadratic formula to help us decide whether or not we can factor. When we have the discriminant, that will, based on the value of the discriminant, will tell us whether or not we can actually factor that quadratic. Okay? So we're going to use that as a tool to see if we can factor. If we can't factor, then we're going to solve by quadratic formula. Now, completing the square is rarely used for solving. It's used more for graphing, which we're going to do later in chapter 11. Okay? So the completing the square is mostly used as our most powerful tool when we're graphing our quadratic equations. We don't use it as much to solve. We can, but most of the time, just use the quadratic formula. Okay? So we're going to start with this. First of all, do I have a quadratic? I don't, but I'm going to end up with one. What do I have to do in order to solve when I have a radical? But I got to rewrite that first before I square both sides. Okay, subtract 4. So let's subtract 4. So I've got x minus the square root of 2x minus 4 equals 0. Now what? Because I can't square both sides yet. What do I have to have before I can square both sides? What do I need to accomplish first? Something with a radical. Before I can square both sides. Be positive. No, there can be a variable inside. That's fine. No, because I'm still going to have a radical. I can't simplify it. I would have x squared minus 2 square root of 2x minus 2x. That still leaves me with a radical. Oh. Where's the radical need to be before I square it? Hey, you know those things that called notebooks where you take notes? Maybe solving radical equations, maybe the last chapter that we just did. You took that test. You did not. Isolate it. What does it mean to isolate? Get it by itself. So how do I get this away from everything else? Add to the other side. So I have x minus 4 equals square root of 2x. Now I can square it. Got to isolate your radical first. Okay? So when I square the square root of 2x, what am I left with? 2x. What about when I square x minus 4? Got to write it twice. And then we distribute. Sound effects make it better. So let's get it into standard form. Group everything to one side, combine all your like terms. Okay? So now, once we have it in standard form, it comes down to the idea of can I factor it or not? We're going to use the discriminant. What's my formula for the discriminant again? There you go. B squared minus 4AC. Okay, what's the value of B? What's the value of A? What's the value of C? Okay. What's negative 10 squared? What's negative 4 times 16? And when I subtract those, what do I get? $36. Can I square root that? Yeah. That means I can factor that. If your discriminant is a perfect square, then that means that you're going to have two rational, real answers. Two rational, real solutions. If you have rational, real solutions, then that means that can be factored. If it can't be factored, well, then we've just done like half the work for quadratic formula, so then we're still halfway there. So, what is, words, I have those. How do I factor this quadratic? What am I looking for? The product of what? Nope, that's the one I need the sum for. I need the product of 16 and a sum of negative 10. Okay? So what two numbers give me a product of 16 and a sum of negative 10? Negative 2 and negative 8. Okay? And since I don't have a leading coefficient, I don't need to split it. I can just write it as x minus 2 and x minus 8. Now what do I do to continue to solve? Set both to 0. Good job. Okay? Now we got to check. And we have to check because we have that radical. All right. When you have radicals, when you've got rational equations with the fractions, then you need to make sure that you plug those back in to check. A lot of you missed that on the Chapter 8 exam. You forgot to check your answers. We have to look for extraneous. These are just possible solutions to that equation. So I want to check. 8 minus 2, the square root of 2 times 8 equals 4. What's 2 times 8? What's the square root of 16? Does 8 minus 4 equal 4? Okay, that one's good. And 2 minus square root of 2 times 2 equals 4. What's 2 times 2? 4. What's the square root of 4? Does 2 minus 2 equal 4? No. So that one's extraneous. Our only solution is 8. So I didn't start out with a quadratic, but I used quadratics to solve. Never said it wouldn't be. A lesson that you should learn early in life. The more math you do, the more work you get. Just wait till you take your first college math course. Those are super fun. This, to see if I could factor. If you're having trouble figuring out whether or not you can factor it, this will tell you whether or not you're wasting your time. If it's a perfect square, then it means we can factor. So if you end up getting 1, 0, 1, 4, 9, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. But if you get something that you can't square root, then just go straight into quadratic form. Okay? Do I have a quadratic? No, but we're going to end up with one. Last chapter, or last section, when I had those fractions, as my coefficients. What did I do to get rid of those fractions? Not the opposite. I need to multiply. What am I going to multiply by, though? What about what kind of denominator? Close. Common denominator. Multiply by your least common denominator. Okay? Well, now my denominators are binomials. So my factors are x minus 1 and x plus 1. Or 2. Sorry. X minus 2, x plus 2. So what's my least common denominator going to be? It's going to be both of them together. X minus 2 and x plus 2. So I need to multiply everything by x minus 2, x plus 2. That's going to get rid of my fractions. Make them go away. So 5 times x minus 2, x plus 2 over x minus 2. Plus 4 times x minus 2, x plus 2, all over x plus 2. Equals 1 times x minus 2, x plus 2. That's a 2. Believe it or not. 2. That's a 2. So what cancels in the first one? What cancels in the second one? What cancels in the last one? Nothing. So let's distribute. What's 5 times x plus 2? 5x plus 10. Distribute again. And distribute again. Go ahead and take a minute and combine all your like terms, get that in standard form. What 9x minus 6. You want to try and keep that positive. So move everything over to where a positive squared term will be. It just makes everything easier. Okay? So let's ask ourselves, can we factor? So we're going to use our discriminant again to see, can I factor, or am I wasting my time trying to figure out whether I can or not? B squared minus 4ac. What's my b value? 9 squared minus 4. What's my a value? And my c value. Okay? Negative 9 squared. 81. Negative 4 times 1 times negative 6. Okay? And add those. Can I square root 105? And the answer is no, I cannot factor. So then we'll just go into quadratic formula. Luckily, we already started it. We didn't have to work. What's my quadratic formula? Okay, so since I used the discriminant to see whether or not I can factor, I already did that part. So I don't have to do it again. We already did it. We already solved that. That's 105. So I just need to fill in negative what? What's my b value? Negative 9 plus or minus square root of 105 over 2 times the a value. I already didn't have to work. Okay? If I have negative 9, what does that simplify to? Positive 9. Can I simplify the square root of 105? By what? So if you split 105 into 5 and 21, can I square root either of those? Okay. Does 21 have any factors that are square roots? Or perfect square roots? No. So I can't simplify 105. And 2 times 1 is 2. There we go. We did it. So if I can square root my discriminant, that means I can factor. If I can't, then just finish quadratic formula. Okay? Notice we haven't actually started with any quadratics yet, but we're still using those methods to solve. So now we're going to get a quadratic, but we're going to have a little shortcut. Okay? So standard form, what would standard form look like? What was the middle term? Okay? What do you notice about all three of those terms? They have a common factor of 4. So we can factor out that 4. If I factor out 4, what am I left with? I don't need to complete the square. I'm just factoring out a 4 because all of these have a common factor of 4. So, now, can I factor this? Oops, that's the eraser. I don't want the eraser. Highlighter. There we go. Can I factor this? Is anything multiplied to 1 that adds to -3? No, because it's 1 and 1. It ain't going to happen. Okay? I can't factor it, so I have to use quadratic formula. I don't need to use the original for the quadratic formula. If I factor out the 4, I can use quadratic formula with this new factored equation. So, x equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. What's my new b value? -3. -3 squared minus 4. What's my new a value? 1. What's my new c value? 1. All over 2 times 1. A lot easier to simplify rather than starting with the original. Can you start with the original? Yes. But you're going to have to simplify your quadratic later. It's much easier to factor out your GCF first, then use your quadratic equation because it's doing that simplifying in the beginning. -3 becomes +3. Good. -3 squared is 9. 4 times 1 times 1. 4 over 2. And then we can finish it off. 9 minus 4 is 5. And now it's already simplified. If you plug the original values back into your quadratic formula, you would have ended with x equals 12 plus or minus square root of 80 over 8, which requires more simplifying in order to get here. You'll get there, but save yourself the time, especially when you've got 40 minutes to answer questions. Anything you can do to save yourself some time or reduce possible computation errors is going to be better for you. Okay? Golly, dog, I hate fractions. What should I do? Not an option. What am I going to do with the common denominator? Yep. What's my common denominator going to be? 8. Multiply, 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 multiply. What's 8 times 5/8? Which equals 5. 8 times what? What's 8 times -1/2? What's 8 times 0? So, let's see. Can we factor it? Can we factor? Okay. B squared minus 4ac. What's my b value? What's my a value? And c? What's 8 squared? And -4 times 5 times -4. Add those together. Can I square root that?
Yeah, 12.
So that means yes. I can factor. So, you're going to need to remember how to factor these, especially because you've got a semester exam coming up in a month. What do I do differently when I have got the leading coefficient?
Everything on the left side.
You're thinking completing the square. I want to factor. There you go. What does that give me?
-20.
Okay.
And it gives you like this weird answer that you have to do something with it.
Prior knowledge. Oh, school is the worst. What gives me a product of -20 but a sum of 8?
Oh.
10, -2. So we can split 8m, 5m squared plus 10m minus 2m minus 4 equals 0. So we can factor by grouping. Bringing January back around, full circle. Necessary skills, you'll need them. You have a major exam that is 20% of your final grade in a month. So it helps you review this stuff while we're here. Okay, I'll put in 0. Thanks for letting me know. Factor by grouping. What can I factor out of the first two? 5m, which leaves me with what? Okay, what do I factor out of my second grouping? Leaves me with? Okay. So my two factors are? Hopefully that jogs your memory and looks a little familiar. Alright, so continue to solve. Now that I have it factored,
We're distributing that 5m. Why isn't it 5m?
it was 5m squared. I factored it out. I'm not
But you
distributing.
put it back in the parentheses. Is that distributed? Or is
It's actually, we're
that...
actually,
Oh, I know what you're doing.
okay, you're good. We're factoring it again.
Here, you take the 5m and yes,
Because actually what we're doing is, I have this.
and you have two of them.
Yeah. Just grab my highlighter. I know. I'm just doing it for every. I've got two terms that have the common factor of m plus 2. So I'm factoring out m plus 2, which leaves me with the 5m minus 2. Okay? Alright, so it's factored. Now what? Set both equal to 0. 5m minus 2 equals 0. M plus 2. I'll give myself a little bit more space. M plus 2 equals 0. This one does, yeah. What about top one? Add 2. 5m equals 2. M equals 2 fifths. There we go. There are two answers. Okay, so the first two that we solved were not quadratics, but through our process of solving radicals and rationals, we often end up with quadratics, so then we can use our quadratic methods to solve. These two were quadratics, a little bit of a shortcut with quadratic formula, how we get rid of our fractions by multiplying by the LCD, solving our quadratics. The last two are not going to be quadratics, but they're going to mimic quadratics. They'll be quadratics in their nature. Okay? And so again, we're going to continue using these quadratic methods in order to solve. Okay? What do we notice about this equation? Power of 4. So the fourth power. But it mimics a quadratic equation. ax squared plus bx plus c. Alright? I have three terms. But instead of to the second power and the first power, it's fourth and 2. So my exponent was doubled. Think way back, December time. Not really. Exponent rules. X to the fourth is equivalent to x squared squared. X squared to the second power. Okay? And so what we're going to do is we're going to use substitution. We actually used substitution back when we did factoring. We just didn't solve. We used substitution to factor. Now we're going to use substitution to factor and solve. So what we're going to do is we're going to say, let's let x squared equal a. I'm just picking another letter at random. And anywhere that I have an x squared, I'm going to replace it with a. So if I have 9x to the 4th, which is x squared squared, x squared squared, plus 5x squared minus 4. Anywhere I see an x squared, I'm going to replace it with an a. So I have 9a squared plus 5a minus 4 equals 0. Now I have a quadratic. So I can solve using my quadratic methods. You'll want to solve this by factoring. Using quadratic formula is going to cause probably more headaches than it's worth. So, 9 times negative 4. So I'm looking for a product of negative 36, but a sum of what? Sum of 5. Okay? So what two numbers? So 9a squared, let's split 5a into 9a minus 4a. What am I going to factor out of my first grouping? Which leaves me with? Good. Second grouping? Leaving me with? Two factors are? Now, once it's factored, we go back. Once factored, go back. So wherever we see an a, we're going to replace it with x squared. Once we have it factored, change it back. Wherever I see an a, I'm going to replace it with x squared. So 9a minus 4 is going to turn back into what? 9x squared minus 4. And a plus 1 turns into x squared plus 1. Now we can use our square root property to solve both of those. We'll still set them equal to 0. Okay, I want to solve that first one. 9x squared minus 4 equals 0. Yeah, absolutely. Move forward. 9x squared equals 4. Now what? Not yet. Divide by 9. Then we square root. Equals 4/9 square root. So, x squared equals what? And? Say again? Gotta have the plus and minus. Because you're gonna have two answers, not x squared. Get rid of that. X squared. What's that squared? Get out of here. Alright, so x equals plus and minus 2/3. Okay, so there's two answers. Now we're going to get two more. X squared plus 1. X squared equals negative 1. Square root. X equals and positive and negative I. So 1, 2, 3, 4 answers. We're going to talk about something next week called the fundamental theorem of algebra, which involves this idea. Exponent of 4, 4 answers. Exponent of 2, 2 answers. Fundamental theorem of algebra. Okay? so we've got one more. Again, it is not a quadratic. Well, actually it is, but it's got some extra parentheses in it. Yeah. We're going to use substitution again. Do not waste your time by expanding this, distributing this, combining like terms, and then going backwards. You're doing too much. It's already modeled in something quadratic, so we're going to do substitution. We're going to say, let's let x minus 3 equal something else. Much simpler. So instead of having x minus 3 squared, we're going to have a squared. Instead of having 3 times x minus 3, we have 3a. And then we still have the negative 4. So we can factor it. This one's easy to factor. What multiplies to negative 4 but adds to negative 3? Other way around. Negative 4 and 1. Now that it's factored, we go back. Replace a with x minus 3. X minus 3 minus 1. And x minus 3 plus 1. Combine like terms. And then you guys know how to do that. Yeah. That's what I'm saying. Way less work to do it this way. Then expand all that out, and then recombine like terms, and then refactor. So I took this, I factored it, and then I took a, and I put the x minus 3 back. So I had x minus 3 minus 4, x minus 3 plus 1, and then just simplify.
Okay, so that one's gone.
Well, it was, I rewrote it, factored it, and then wrote it back. So it was like I substituted, made it easier, and then put back the hard part. Now, I want you to be careful. We're going to go to alternate reality real quick. I should have made this one a little bit more difficult to factor, but I wanted to be nice. So let's say, where was a good one? We had this factor. We factored by group or factored by substitution. We end up with 5a minus 2 and a plus 2. Okay, so we have 5a minus 2 and a plus 2. All right, so we're taking this and pretending that's what we had here, and then we're going back. We're going backwards, and I need to substitute this back in. Okay. Be really, really careful because you've got that multiplication. You have 5 times that value. When you substitute back in, it's 5 times x minus 3, which means you have to do distributive property first before you do combine like terms. So be really, really careful if you factor and you have multiplication with substitution. You have to do that multiplication. This one will still stay the same because it's just combining like terms. But here you got to be really careful and distribute first before you combine like terms. Otherwise you'll mess it up. Okay, so that's just a little side note, alternate reality there. Enjoy the little trip through the dimensions. And that's it. Questions, comments, concerns, queries, or conundrums?